Today we're going to be discussing Grade 8 Math, the chapter Rational Numbers. Why do we need whole numbers? Imagine you have to solve an equation where x plus 10 equals 10. You can't use a natural number to solve this equation. We need a whole number. So for this equation, x equals 0 is the answer, and 0 is a whole number. Whole numbers start from 0, like 0, 1, 2, 3, etc., while natural numbers begin with 1, and they go on like 1, 2, 3, but they excluding 0. So 0 is not a whole number, a natural number. So in the diagram on the right, we can see the difference between whole numbers and natural numbers. Why do we need integers? Imagine to solve an equation where x plus 23 equals 10. You can't use a natural or a whole number to solve this equation. We need an integer. So the answer to this equation is x equals to negative 13. And negative 13 is a negative integer. Whole numbers start from 0, like 0, 1, 2, 3, etc., while integers can be negative. So the diagram on the right helps us distinguish between integers, whole numbers, and natural numbers. Now, why do we need rational numbers? Imagine you have to solve an equation where 2x equals to 7. You can't use a natural, a whole, or an integer, a whole number or an integer to solve this equation. We need a rational number. So for this equation, x equals to 7 by 2, and 7 by 2 is a rational number. I'll get to what rational numbers are in the next slide. So the diagram on the right helps us distinguish between rational numbers, integers, whole numbers, and natural numbers. We can see that integers is a subset of rational numbers, whole numbers are a subset of both integers and rational numbers, and natural numbers are a subset of whole numbers, integers, and rational numbers. So what is a rational number? A rational number is a number that can be represented in the form of p by q, where p and q are integers and q is not equal to 0. For example, 2 by 3, negative 5 by 6, 1 by 4, 5, and negative 9 are all rational numbers because p and q are integers and q is not equal to 0 when we represent these rational numbers. All integers are rational numbers. For example, if we take negative 15, this can be written as negative 15 by 1, and this is in the form of p by q. If the numerator and the denominator of a rational number are divided or multiplied by the same number, we get another rational number. For example, if we take 2 by 3 multiplied by 8 by 8, that's 16 by 24. And this is a rational number. Because if you see 2 by 3 multiplied by 8 by 8, it's just 2 by 3 multiplied by 1, which is 2 by 3. So these are rational numbers. If we divide by the number 4 on both sides, you'll get a 2 by 3 divided by 4 by 4. You'll get 2 by 3 again. Or you'll get it in the form 4 by 6, which is simplified to 2 by 3. So 2 by 3, 4 by 6, and 16 by 24 are all the same rational number. This means they're called equivalent rational numbers. Now, what is closure? If you perform an operation on two numbers from a set, the result is also in the same set. So, for example, let's take the closure for whole numbers. For addition, 0 plus 10 equals 10. So this is closed because we have a rational number on the left and the right side of the equation. Now subtraction. 5 minus 13 equals minus 8. This is not closed because on the left side we have two whole numbers, but on the right side we have minus 8, and minus 8 is not a whole number. For multiplication, it is closed because if you see the equation 0 times 3 equals 0, the left side is, we have two whole numbers, and on the right side we also have a whole number 0. For division, we see that this operation is not closed because 5 by 7 is a rational number. So we have two whole numbers on the left side and a rational number on the right side. So division is not closed because 5 by 7 is not a whole number. Now, closure for integers. Addition is closed for integers because we can see 0 plus 10 equals to 10, and we have an integer on both sides of the equation. Subtraction and multiplication are also closed because we see that there's two integers on the left and right hand side of the equal sign. Division is not closed because we can see 5 and 7 are integers, but 5 by 7 is a rational number. So since 5 by 7 is not an integer, division is not closed for integers. Now closure for rational numbers. Addition, subtraction, and multiplication are closed because we can see that if we add, subtract, or multiply two rational numbers, we'll get another rational number. However, division is not closed because if we divide, let's take 2 by 3 as a rational number. Let's divide 2 by 3 by 0. We're going to get undefined because x by 0 is not a rational number. So division is not closed for rational numbers. Now, what is a commutative property? This exists when you can swap two numbers without changing the result. For example, a plus b equals b plus a, or 10 plus 8 equals 8 plus 10, which is 18. So addition has the commutative property because the order doesn't change the result. Is subtraction commutative? Let's take the example of 10 minus 8. So 10 minus 8 is 2. But 8 minus 10 is minus 2. So 10 minus 8 is not equal to 8 minus 10. So the order changes the result for subtraction, hence subtraction is not commutative. Is multiplication commutative? Let's take a multiplied by b and b multiplied by a. Or 3 multiplied by 4 is 12, and 4 multiplied by 3 is also 12. Here the order doesn't change the result. So multiplication does have the commutative property. Now what about division? For example, 10 by 2 is equal to 5, but 2 by 10 is 1 by 5. So 10 by 2 is not equal to 2 by 10, which means the order changed the result. So division does not have the commutative property. What's the associative property? This is when we can change the order of numbers in a group and the result stays the same. For example, a plus b in brackets plus c is equal to a plus b plus c in brackets. Similarly, ab in brackets multiplied by c is equal to a multiplied by bc in brackets. So addition and multiplication have the associative property. So to summarize rational numbers and their properties, addition and multiplication have both the commutative and associative property, while subtraction and division have neither the commutative nor the associative property. You can pause the video here if you want, because this slide is really important to remember the properties for addition, multiplication, subtraction, and division for rational numbers. Thank you.